If you are seeking older electrical code books, a potential resource is online at the specific website. They also offer a CD containing some older editions. Understanding how to navigate older code books can be a significant asset for a number of reasons. Firstly, historical context. Older editions provide insights into the evolution of electrical practices. You can trace the development of specific requirements and understand the reasons behind current regulations. Secondly, research and documentation. For writing about codes or conducting research on electrical standards, having access to older code books is invaluable. It allows for accurate historical referencing. Thirdly, comparative analysis. By comparing different editions, you can identify changes and trends in electrical safety and installation practices. This can highlight areas where codes have become more stringent or more relaxed. Fourthly, understanding legacy systems. Older buildings often have electrical systems that were installed according to previous codes. Familiarity with these codes is essential for safely maintaining or upgrading such systems. Fifthly, improved inspection skills. Understanding how codes have evolved can enhance inspection skills by providing a broader perspective on what to look for and why certain practices were once acceptable or required. Code books are updated periodically to reflect new technologies, safety concerns, and industry best practices. The National Electrical Code, or NEC, is revised every 3 years. It's important to use the edition that is adopted by the local jurisdiction, as there may be variations or amendments. Always refer to the current adopted code for new installations. The main service disconnect, for example, which is required to be outside a building or near the point of entry into the building, has been around since the 1940s, even though it might not have been enforced locally until later. This highlights the importance of understanding both the code requirements and their local adoption and enforcement. Consider key changes in code requirements over time. Grounding and bonding requirements have evolved significantly, reflecting a better understanding of electrical safety. Receptacle requirements in dwellings have changed to include ground fault circuit interrupter, or GFCI, and arc fault circuit interrupter, or RFCI, protection in specific locations. Wiring methods have also seen changes to reflect new materials, technologies, and installation practices. Code adoption varies by state and locality. Some jurisdictions adopt the NEC with minimal changes, while others introduce significant amendments. It's crucial to know which edition of the NEC is in effect locally and any local modifications. Firstly, state regulations. States typically have boards or agencies responsible for adopting and enforcing building codes, including the NEC. These agencies may amend the NEC to suit local conditions or policy priorities. Secondly, local amendments. Cities, counties, and other local jurisdictions may further amend the state-adopted NEC to address specific needs or concerns. These amendments can vary widely from one locality to another. Thirdly, enforcement practices. Even when the NEC is adopted without amendments, local enforcement practices can differ. Some jurisdictions may have stricter interpretations of the code or more rigorous inspection procedures. Understanding the roles of various stakeholders is also important. Firstly, electrical inspectors. The electrical inspectors are responsible for verifying that electrical installations comply with the NEC and local amendments. They play a crucial role in ensuring electrical safety. Secondly, electrical contractors. Electrical contractors are responsible for installing electrical systems in accordance with the code. They must stay up to date on the latest code changes and best practices. Thirdly, homeowners and building owners. Homeowners and building owners are ultimately responsible for ensuring that their electrical systems are safe and compliant. They should work with qualified electrical contractors and be aware of their responsibilities under the code. When researching historical code requirements, consider the following steps. Firstly, identify the relevant code edition. Determine which edition of the NEC was in effect at the time the electrical system was installed or modified. Secondly, obtain a copy of the codebook. Locate a copy of the codebook for the relevant edition. This may involve searching online resources, libraries, or historical societies. Thirdly, review the relevant sections. Focus on the sections of the codebook that pertain to the specific electrical components or systems you are researching. Fourthly, consider local amendments. Check for any local amendments that may have been in effect at the time. These amendments can significantly alter the requirements of the NEC. Fifthly, consult with experts. If you have questions or need clarification, consult with experienced electrical inspectors, contractors, or engineers who are familiar with older codes. Understanding grounding requirements over time is essential. Older codes may have had different grounding requirements than modern codes. For example, the use of equipment grounding conductors and ground fault circuit interrupter, or GFCI, protection has become more widespread over time. Receptacle requirements have also changed. The introduction of tamper-resistant receptacles and arc fault circuit interrupter, or RFSI, protection in dwellings has improved safety. Understanding wiring methods is also important. Older codes may have permitted wiring methods that are no longer allowed. For example, the use of knob and tube wiring is generally prohibited in new installations. The historical context of code requirements provides a valuable perspective on electrical safety. Understanding why codes have changed over time can help to identify potential hazards and improve electrical practices. By tracing the development of specific requirements, you can gain a deeper appreciation for the importance of electrical safety. By comparing different editions, you can identify trends in electrical safety and installation practices. This can highlight areas where codes have become more stringent or more relaxed. Familiarity with older codes is essential for safely maintaining or upgrading such systems. Understanding how codes have evolved can enhance inspection skills by providing a broader perspective on what to look for and why certain practices were once acceptable or required. To clarify further, consider changes related to ground fault circuit interrupter, or GFCI, protection. GFCIs are designed to protect people from electric shock by detecting small leakage currents. The NEC has expanded the requirements for GFCI protection over time. Older codes may not have required GFCI protection in as many locations as modern codes. Common locations that now require GFCI protection include bathrooms, kitchens, and outdoor receptacles. Similarly, arc fault circuit interrupter, or RFSI, protection has seen increasing usage. RFSIs are designed to protect against electrical fires by detecting arc faults, which can occur when insulation breaks down or connections become loose. The NEC has expanded the requirements for RFSI protection in dwelling units. RFSIs are now typically required in bedrooms, living rooms, and other areas where arc faults are more likely to occur. For wiring methods, older codes may have allowed aluminum wiring for branch circuits. Aluminum wiring can become loose over time, creating a fire hazard. The NEC now has specific requirements for the installation and termination of aluminum wiring. Another aspect involves service entrance requirements. The NEC has requirements for the size and type of service entrance conductors, as well as the location of the service disconnect. The main service disconnect must be readily accessible and capable of disconnecting all power to the building. The placement of the main service disconnect has been around since 1940s, even though not enforced until later in some areas. Branch circuit protection is another key area. The NEC has requirements for the overcurrent protection of branch circuits, including the size of the circuit breakers or fuses. Overcurrent protection is designed to protect conductors from overheating and causing a fire. The size of the overcurrent protection must be matched to the ampacity of the conductors. Consider also equipment grounding. The NEC requires that all metal enclosures of electrical equipment be grounded to provide a low impedance path for fault current. Equipment grounding helps to protect against electric shock. The equipment grounding conductor must be sized according to the size of the circuit conductors. Bonding requirements also affect safety. Bonding is the process of connecting metal parts together to create an electrically conductive path. Bonding helps to equalize voltage potentials and reduce the risk of electric shock. The NEC has specific requirements for bonding different types of metal parts. Finally, look into surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning or other events. The NEC has requirements for the installation of surge protection devices in certain applications. SPD can help to prevent damage to sensitive electronic equipment. To effectively research and write about codes, firstly, gather the code books. Obtain copies of the NEC editions you want to research. Secondly, create a timeline. Develop a timeline of key code changes for dwellings. Thirdly, analyze specific sections. Compare the requirements for specific electrical components or systems in different editions of the NEC. Fourthly, document local variations. Research any local amendments that may have been in effect at the time. Fifthly, provide context. Explain the reasons behind code changes and their impact on electrical safety. Sixthly, include examples. Provide real-world examples of how code changes have affected electrical installations. Seventhly, cite sources. Properly cite all sources of information, including codebooks, articles, and expert opinions. Eighthly, review and edit. Review and edit your work carefully to ensure accuracy and clarity. By researching older codebooks, you can gain a deeper understanding of electrical safety and improve your skills as an inspector, contractor, or engineer. For example, consider the evolution of receptacle spacing requirements in dwelling units. The NEC has requirements for the maximum spacing between receptacles along walls. These requirements are designed to ensure that extension cords are not used as a substitute for permanent wiring. The receptacle spacing requirements have changed over time to reflect changing lifestyles and the increasing use of electrical appliances. Consider also the evolution of lighting requirements. The NEC has requirements for the type and location of lighting fixtures in dwelling units. These requirements are designed to ensure adequate illumination and safety. The lighting requirements have changed over time to reflect new technologies and energy efficiency concerns. The NEC addresses the safe installation of electrical systems in dwelling units. This includes requirements for wiring methods, overcurrent protection, grounding, and bonding. The NEC is updated every 3 years to reflect new technologies and safety concerns. Always consult the latest edition of the NEC for the most up-to-date requirements. Local codes may have additional requirements. Check with the local authorities to determine which codes are in effect in your area. Adherence to code requirements is essential for electrical safety. Improperly installed electrical systems can create a fire hazard or electric shock hazard. Hire a qualified electrician to install or repair electrical systems. A qualified electrician will be familiar with the NEC and local codes. A qualified electrician will also have the necessary skills and experience to install electrical systems safely. Check the credentials of the electrician before hiring them. Make sure the electrician is licensed and insured. Ask the electrician for references from previous customers. Get a written estimate before work begins. The estimate should include the cost of materials and labor. The NEC is a comprehensive set of standards for electrical safety. It is important to understand and follow the NEC requirements to ensure the safe installation and operation of electrical systems. Consider requirements related to electrical panels. The NEC has requirements for the location, size, and construction of electrical panels. Electrical panels must be accessible and properly labeled. The NEC has requirements for the wiring of electrical panels. All connections must be tight and secure. The NEC has requirements for the grounding of electrical panels. The electrical panel must be properly grounded to protect against electric shock. The NEC also has requirements for the overcurrent protection of electrical panels. Each circuit must be protected by a circuit breaker or fuse. The circuit breakers or fuses must be sized according to the ampacity of the conductors. Consider changes in the requirements for swimming pools, spas, and hot tubs. These locations present unique electrical hazards. The NEC has specific requirements for the wiring and grounding of these locations. Ground fault circuit interrupter, or GFCI, protection is required for receptacles and equipment in these locations. Bonding of metal parts is also required to equalize voltage potentials. Surge protection is recommended to protect electronic equipment from voltage surges. Consider also the evolution of renewable energy systems. The NEC has requirements for the installation of solar photovoltaic or PV systems and wind turbines. These systems must be installed safely and in accordance with the NEC requirements. The NEC also addresses the interconnection of these systems with the utility grid. As you research electrical codes, always use common sense and good judgment. If you are unsure about something, consult with a qualified electrician or electrical engineer. Electrical safety is everyone's responsibility. By following the NEC and local codes, you can help to protect yourself and others from electrical hazards. The understanding of the evolution of electrical codes can provide a deeper appreciation for the importance of electrical safety and best practices.